So, welcome everyone to this Draco compiler development stream. This is trying to be a bit of a lesser themed one than the previous agenda with the REPL. This time we're going to tackle a bunch of issues that we have had open in the compiler for quite a while. And we just never got around to doing them. Hopefully these are not too hard. We won't have to dissect the entire compiler for them. And they're a good excuse to sort of show off the different functionalities and how they work in the compiler itself. I've listed 4 issues here. I don't know if we'll tackle all of them. We'll see. None of them seem particularly hard. But we definitely won't tackle them in order. But let's quickly go through what the issues are, what we need to fix today. So the first one we have is actually opened yesterday. Someone noticed that we don't have the equality operators for enums, so we cannot use equals, equals, and bang equals for equating enum types. Of course, we don't have our own enum types yet. There's no way to define them, but someone tried to play around with an external DLL, I believe, or the BCL types, and noticed that they had to use dot equals. So this is something we're missing and something we should support. The other one, there's no description here, but it's pretty self-explanatory. We have no documentation available in the BCL references that we're loading for the compiler. So if you take a look at the tooling integration here, let's write a sample function, something like func add. That just adds 2 numbers. We can actually have a documentation comment that starts with 3 slashes instead of 2. And here we can basically write markdown. And when you reference it, you actually have the summary here. For some reason it doesn't, because this is not a documentation comment. So in the completion, you get a render of this markdown. And also if you hover over the thing, it will show you the documentation. But if you try to hover over some BCL reference, like system.console, it will unfortunately just show nothing. So this is something to work on as well. The third issue is that we have quite misleading overloading errors when the inference fails somewhere. So actually, this is from another issue, that if you try to add 2 vectors together, for example, and you provide no arguments, so there's no matching constructor for it, it will actually say that the addition itself is ambiguous. Well, of course, next to not finding an overload for vector 2, it will say that the addition itself is ambiguous, and it will list all these globally available overloads, just because it couldn't resolve the overload for this vector call. So we have a case of basically cascading errors. Now we have one more, which is implementing the rest of the array type. So this is pretty easy to demonstrate. Let's quickly write a function that can construct an array for us. The easiest way to do this is by varargs as of right now, because we don't have any other syntax to construct arrays yet, as we haven't felt the need. But if you construct an array, you cannot actually for each over it. So you can't say element in A and then just right line the element, because there is no get enumerator, and this is because arrays are a little special in the runtime. the fact that an array implements I list and I read only list, the generic versions, is only materialized during runtime. So, and our compiler obviously does not know that, so it cannot pretend that arrays implement these interfaces. So this is also something we'll have to do. Let's actually see what's the easiest to tackle. I believe it would be the documentation. So we have a type called metadata reference. And basically it has a metadata reader and the document, the XML document optionally next to it. And the metadata reference is basically just a DLL ref that we can construct from a bunch of different sources. From an assembly, which is mainly used for testing or some reflection-based code gen. PE streams are generally how you load them from files. And back then we did this really weird build pattern thingy, or rather Fluent API thingy, where you can attach a documentation to a metadata reference, but honestly, it's just painful. What I'd rather have instead is take a file stream, or rather a file path itself, and try to fetch the documentation XML, because it's usually right next to the binary file itself. And yeah, for example, the BCL as well. All the documentation is right next on the disk with the same name, just with a different extension. So I would say let's try to refactor this a little. So what do we want to do here? This constructor is fine here. It's a private implementation anyway, but I want to get rid of this with documentation. And I want to have something called from file. And we're going to take the path as a string. Someone probably will hate me for this. We might replace it with a URI later. I'm not sure. And I suppose it doesn't hurt to take the XML documents here either. Since we are getting rid of the builder API, we want to make sure to support the same functionality. So we're just going to introduce them as optional arguments. And we need to, of course, pass that in here. And to not forget it, we're going to make this non-defaulted. And from file, well, maybe we could have an option to turn off fetching the documentation, but for now we're just going to automatically do it every time. I'm gonna just leave a note here. But other than that, we assume that the documentation is at the same path, just with an XML extension. And fortunately we have change extension for that. I'm not sure if the extension takes the dot or no. Let me check the documentation for it. With or without the leading period. Okay, I am fine with that. And I know that how I'm going to write it is gonna cause some race conditions, but I'm not sure how else to write it. To be honest, I'm not really well versed with file operations, so I'm just going to write the simplest way, which is check if it exists, and if it does, we're going to open it. So something like so. Oh yeah, the XML document has a really weird API. If I recall correctly, there's no load from file or something. We only have load after the fact. Is that right? Yeah, yes it is. So we could use some docstream, which is if it exists, we're going to open it for reading, otherwise it's a null. We're also going to open the binary file itself. And this returns a stream, I hope. Yes, it does. And the doc XML is going to be a little tricky. Actually, let's make this null by default, and if docstream is not null, yeah, we're going to load it. And finally, we can construct it from a stream. I wonder if we should construct the document itself from a stream here as well, but I'm just not gonna worry about that. That's easy to shift down later. Okay, this looks good to me, and we probably want to go through all the references to this function, and there's quite a lot, mainly for tests though, so we're going to ignore tests. I'm going to open this on a side window, so you won't see it, but I'm just gonna close off all the test references. So this is the method that we just wrote. This is test code again. Okay, now this is promising because this is, for example, the language server itself. So the language server does a design time build, and that's important because the design time build is how we retrieve all the metadata references that the project will reference. So that's how the language server essentially knows the BCL by default. And if you reference a NuGet package, this is how it knows where to find that DLL stashed on your computer. And the language server itself is the thing that will display the documentation. So this will be a pretty important change here. We're going to replace this with our new from file API, and we're going to pass in the file info's full name. So this is one changed. This is REPL code that we can't change yet because the REPL doesn't resolve metadata refs properly yet. This is test code, again test code, and now we're going to the CLI of the compiler, and we can basically just do the same. We can just replace this with from file. Same here. And we got a few more places. This is the dev host that can stay like this. Okay. So let's check it out. And the simplest way, I believe, is just to rebuild the language server. Unfortunately, I have to close the VS Code editor for that. Otherwise, it won't let me reinstall it. Okay, let's see if this worked. I wonder when the thing comes alive now. Okay, wonderful. It's not formatted nicely, but it's documentation, which is way more than what we had before. So now you can start things like write line. Oh, we have a crash somewhere. Let's actually try to investigate where, since we're doing a maintenance stream. Okay. Oh, we have an error in the documentation retrieval. Look up by prefix documentation name. I guess it's a little crafty. Okay, I suppose this isn't the correct assumption. Let's see if it was thrown by this line 73. Yeah, it's probably this one. So, well, we can do a check, or we could try to actually debug the language server. You can just attach it. Oh, this is a new kind of window since I updated Visual Studio. So I couldn't find the search box. So this is our lang server running. And let's try to cause the crash, I suppose. Okay, that was really easy. I just typed a W and it popped up. And this is because we're trying to search for an empty string. Or we're trying to look up a symbol by its documentation name. But why exactly do we do that? Okay, so the doc extractor is calling this. That makes sense. But why exactly? Oh, we're trying to build a documentation for read line. Okay. And the read line hit a section called returns. Okay. Which has a C section within. Okay, readline probably references some cross-references something, and within that we have the cross-reference null. Oh, because this isn't a cref, this is a C. This is not a cref, but a C tag. Huh. Okay. I don't want to go too deep into this to fix it because I honestly can't remember what this code does. Wait, no, C tags need to have a cref. Oh, because it can be a lang word as well. Okay, okay. Well, that's pretty easy to fix. Do we have a has attribute or attributes dot contains? Okay, no, dot contains. No. Really? I know that the original I knew that the original thing sucked. The original XML reader, but this much? Oh, hello, Infinite Coder 01. So, I suppose we can just index it and check if it's null. It's really janky. Yeah. Okay, we already have this, and then let's do lang word as well. Well, let's do that in else. So this, if this isn't null, what language is this compiler for? It's for Draco. If you go to github.com slash wrong thing / Draco-lang, you can see our org, and here you can find a bunch of links. We have a language suggestion repo that you can hit up. It's basically where we write our specification, though we're really behind with that. We also have a core library suggestions that basically abandoned because we are not nearly ready to ship a base library. And then we have a compiler which we're working on today, which is pretty healthy and active. Are we going to do self-hosting? Actually, I did an experiment yesterday about this because we have finished some pretty big features, and I tested if it's feasible to self-host the CLI project of the compiler at least. So just the command line interface, the command parser being referenced from NuGet, and basically configuring it with delegate construction and such. So things that got into the compiler pretty recently, and it basically worked. So yeah, it's a long-term goal to self-host, and it does seem more and more feasible, although the language is still really crafty and young to be self-hostable anytime soon. We don't even have user-defined types. It's something that's being worked on at this moment. So if cref is not null, we're going to return this, and if it's not, I guess we try to look for lang word. And I don't even remember what reference documentation element is. So what kind of documentation elements do we have? And can we just return an abstract one? Okay, so we have text documentation elements as well. Or we have code documentation elements too. A raider from Infinite Coder 01. I honestly don't even know what that means. Oh crap, I suppose it means people came over to our stream. I am not good with Twitch chat streaming, guys, so sorry. But welcome everyone, welcome. And thank you for the raid, I suppose. Raid is when someone ends the stream and sends all the viewers to someone else. Oh, okay, okay. Started suspecting that because our numbers just bumped up to 6 from 0. So thank you, thank you. I guess for the default here, we can just construct some placeholder for now, saying that this is an unknown reference element. So people who just dropped in, we are currently debugging a crash in the metadata documentation for the language when you hover over something in the language server. So let's try this again. This shouldn't crash anymore. And now let's reattach our debugger. And see if you're crashing. Oh, we're not, and we have all the documentations. Nice, nice. So let's see if I scroll through the overloads, we get all of them. Well, they're not pretty, but we can fix the rendering later. Our language's goal was to use Markdown. Yeah, this is a language server. That you see, well, you don't see it, but it's running in the background and is started up by the extension that we have for Draco. Well, I wish it was fancier. It's sort of fancy. We also have our own debugger that we wrote for .NET and integrated into VS Code and a bunch of other editors. But the debugger isn't too fancy either. It's pretty crafty as well. Still, it's being worked on actively. So I believe we can tick off BCL documentation. So let's commit this. And let's move on to the next issue. So at the start, we wanted to fix 4 things in the compiler today. 1 is done. So we're going to review and merge that eventually. Let's try implementing the rest of the array type, because that's something that's been really, really bugging me. So as I said at the start of the stream, but let me just repeat it. We have arrays for quite a while now in the language, but basically they are a bit hacky in .NET, and that's because arrays are not known by the BCL. They are materialized during runtime, at least as a type. All we know is that they derive from system.array, which let's actually open something like C# REPL. So I can actually show you what I mean. So if you look at what interfaces system.array implements, you can see that it implements all the non-generic collection thingies that were pretty standard in like old .NET, basically. But if you look at something like an integer array, you can see that it also implements the 2 most important are iRead-only list and iList, the generic versions. And the problem is with that is that our compiler currently doesn't know that arrays implement this, and this is because our compiler has to synthesize all the array types. So let's jump into our array type and see if we can hack these base interfaces in, so we can actually use fancy things like a for loop over them. Because with lists, there's actually no problem. So if we quickly create a list, and the type gets inferred, yep, we can actually use a for loop over a list, but not over an array, sadly. So let's navigate into that part of the compiler, which is going to be mainly symbols work. And it should be synthesized, and here's the array type symbol, which is a generic array. We didn't go for some custom syntax. An array is just like this. So it's a generic type, and internally we compile it down to the .NET array types. Since it's been a while, I've worked on the type symbol API. We're going to peek into type symbol and see our options, what we can override. So we have a way to override the immediate base types, which is good because that's probably what we need. So let's do that. And the two things we need to implement is iList and iReadOnly list. If you look at the others, they're basically covered by iList and iReadOnly list. So iClonable is inherited from system array. Oh wait, that's actually a good point, that we also need to implement system.array as well, because that's our main base type, basically. So from system.array, we get all these, and the rest are from iReadOnly list, which I believe implements iReadOnly collection and IEnumerable, I believe, and then we have iList, which is iCollection, and IEnumerable as well. Is system array an interface? No, it's actually a class, I believe, but we can just ask the REPL. Yep, it's a class. Generally in .NET, you prefix interfaces with I. You have this Hungarian naming, I suppose. Oh, we have a useless cost here. Let's delete that. So, how we're going to get our hands on these custom types? We actually have a mechanism for locating things in the BCL or in any basic referenced thing, which is called WellKnownTypes. WellKnownTypes are things that are well known to the compiler, basically. So all the primitive types, all the operators. This is why we're questioning it. How can you implement a class for a type? Oh, okay. I might have misspoken. It's a base type for us. Internally, we really don't differentiate the two. You have base types, base interfaces. In both cases, what we care about is where a method or a property access or a field reference comes from. Basically, yeah, inherits. Implementation is something that will come from user code, and it's not a mechanism that we have ever worked on. This will come when the user-defined types work gets kicked off properly. Someone is actually working on it and is implementing the really bare bones version of classes. So once that's done, we can have all the nitty-gritty details of implementation versus inheritance, which will actually be quite significantly different in the language, because we want to have a system where you externally implement interfaces for a type, but obviously because of .NET limitations, you can only have one base class. But for external interface implementation, we might look into the proposal of shapes, or I don't know what the proposal is currently called, that deals with these external extensions, basically. So let's add all these well-known things to our compiler, and I can see that system.array is already here, which is wonderful. Let's add the rest. So we will need system.collections. I can't type today. Generic .ilist, and this is going to need a backtick 1. I wonder if our source generator handles this, because this XML is basically translated by a source generator, so we don't have to type out all these references in code. And then we need iRead-only list, and we'll see if we crash and burn. Let's try to compile it. Okay, we apparently don't. Can I open the output generated source? Let's see. Yeah, this isn't valid C#, but that's pretty easy to fix. So let's jump into our source generators and fix this quickly. I believe we have it in the templates, yes. Let's see how we generate this. So this is a Scriban or Scriban, I don't know how you pronounce it, template. It's a DSL for embedding into C# or any .NET program, basically, and it's a really, really nice templating language. And currently I'm trying to locate how we reference types. It's here. And we have a prop name, which is computed from the type.name, and we have a nameify thing. Okay. And it replaces all the dots with nothing. So let's make this a little smarter. So we are going to replace backticks with underscore, maybe. Unfortunately, I'll have to restart Visual Studio because we changed the source generator. And it's really, really not happy about this. But let's see what happens after a restart. Okay, it's still not really happy about this. Let's see what we've done. It's almost like it didn't actually rebuild it. Oh wait, but now our thing is broken. Because we have these weird names. Oh, because I didn't pass in result here. And I have double backticks here as well, so double failure. Okay. Let's do a rebuild and restart again. Let's see if we're building now correctly. Okay, it seems to be fine. Let's check the output. That's the wrong thing. Hello? Okay, finally. Okay, that seems to be good. So, let's get back to where we were. We have all these references now to these needed members, so let's specify it for the array type. We have a declaring compilation where we can access the well-known types. So we need system array. On the declaring compilation might be null. That's a problem. We probably didn't override it somewhere. I really don't want to take a null reference exception. So what we're going to do is make this a lazy member. And okay, Copilot is really lost. I'm not sure why, because we have this pattern repeating all around. We have something called interlocked utils dot initialize default, and I really don't want to have an inline lambda for this. So if WellKnownTypes is null, we're just going to return an empty collection here. So this is how we're going to handle a null ref. Otherwise, we can finally have our 3 base types for arrays. Of course, list we're going to have to generic instantiate because we have our own generic parameter, which is our element type, yes. Why are you not happy about this? Oh, of course, because you will need it as an array. No. Oh, because it needs the containing symbol. The containing symbol can be this dot containing symbol, I suppose. And the same for iRead-only list. Okay, let's see if this works. I have the dev host, which is basically the CLI, set up to point at this project as well. So let me delete all the things we don't need anymore and see if we crash or something. Get enumerator cannot be found for array. Okay, okay. That means that this probably didn't work. Let's see if the declaring compilation for this thing is null or not. Of course it is, because we probably don't take it in as a parameter. So let's override it. let's take it in. And that means that we can actually bypass this null check. Let's see where we're trying to reference array constructor, because we're going to have to rewrite that. Oh, we only have WellKnownTypes here. Oh, because this is why I don't like the new C# primary constructor feature. I mean, in general I do like it, but we have a convention in the source code that we always specify prefix non-static members with this dot. So this is how I usually look up my members, but with this capturing mechanism, we basically lose this ability, and there is no easy way for me to browse my members anymore. It's quite annoying. I believe we have one more here. Yes. Okay, let's see if this builds. Almost. Yeah, it's just this. So let's see now. Oh wow, something that just worked after we fixed the null bug. This is wonderful. So to actually have this reflected in the tooling, let's rebuild our language server. It's not that hard to remember primary constructor parameters, just like regular method params. Yeah, but you can see that types can get really, really big. And it's not exactly like the usual small methods you write. It's usually these massive types we have, and it's not like the type itself is massive. It just it barely has any members. If we just construct a lot of things, so by the time I'm scrolling down all here and try to browse my types without some editor help, by just typing this dot and seeing all the completions, I won't find compilation here. But you know, it's not the end of the world. I still really like the feature, and when we introduced it in the code base, it cut out like a 200 constructors, so, and a lot of useless CRUD basically. So we couldn't rebuild the lang server because we have VSC running in the background. Let's try again. And now if we open it, okay, this is a bit crafty. It infers it to an object instead of an int. So this is something to investigate later. Let's see if we have all our members. Oh yeah, we do. We absolutely do. I wonder if we still need length, as I believe that's inherited from system array. I'm not sure. So let's check it. Are we using any kind of parser or lexer generator? No. I actually have a background in university. I was researching a lot about lexer and parser generators. I know a lot of theory about parsers, but in general, I don't think that they're a really nice tool unless you're prototyping and need something really fast. In general, error recovery or even error reporting is a bit lackluster in my experience. So no, we are just handwriting it, and it's not that complicated. You can actually find our lexer under internal syntax, and here's the lexer and the parser, basically. It's your everyday lexer and parser. The lexer just goes through each character and does its thing. The only fancy thing that it does is that it tracks your state in a stack, because we have an interpolation mode within strings. And the parser is just a regular recursive descent parser with the packret parsing trick for precedence parsing. But even that is factored out into these higher order parsing functions. So if you look at where is parse expression, you can see what I mean. This is basically our precedence table here. So in my experience, especially for deterministic CF, so deterministic context-free languages, writing a parser, especially a top-down parser, is really, really easy. So it didn't even occur to me to use a generator this time when we started the project. So I hope that answered your question, by the way. Let's see if we do have a length member here. We do. That's really good, because that means I can throw out the length member that we had before, that we synthesized for arrays. So array length property can be thrown out. Yes, very much. And even array index property, I believe. Because I believe indexing is contained within iRead-only list. I'm not sure. I never remember what it's called, so I'm going to call get members on it. Oh yeah, it's get item. Okay, and I suppose then iList has set item. Yeah, yes it does. Oh, but the reason we don't want to replace those is because these have custom code generation. Because array indexing is special in the BCL. Not the BCL, what am I talking about? In the MSIL code. So that we're not going to throw out. But array length, for sure, we're throwing it out. Let's see what we're missing. Because for sure I need to delete this somewhere. Okay. Yeah, we just don't need to check for this anymore. I really, really like getting rid of edge cases like this. But I do wonder if we can get rid of indexing as well. We probably could. It's just that we would have to fix code gen, which I really, really don't want to do now. Let's see if we're still working. And let's actually print the length of the array as well. Semicolon. Yep. Okay, that just works. That's really nice. And the reason I did that is because I noticed that we didn't have documentation for the array. It's something that we just did. So if you notice, long length has a really nice documentation section, but length didn't, and this is because it's our own synthesized documentation, synthesized symbol. So now, if we recompile the language server and reference the length property from BCL, we should have documentation for that as well. Let's wait a second for it to kick in. Yep. It's maybe a bit outdated because it's system.array, but it's fine. What I don't understand is why we are insisting on this being an object. Can I pass it a function that takes in a list? So can I do this? I should be able to, right? Now we should see that thing twice. Yeah. So this is probably some priority thing that we haven't done yet, probably because system.array implements the non-generic versions of iList and iRead-only list. So we're going to need to check out why this priority is not in order. But this is already within my book, so we're going to commit this. And again, something to consider is throwing out our own indexers as well. And just referencing the built-in ones and adding a check in CodeGen instead of doing this. So what else do we have for today? We have equality operators for enums, and we have fixing the misleading overload errors. Now, the overload errors are quite boring, as in it's just type checker code and not the actual type checking part of it. So we might not tackle that today, and I might do that off camera. But I wonder how we can do equality operators for enums easily. The thing is that if we go to something like SharpLab and define some enum, so if, as you can see, enum members are basically just basically constants within the sealed class foo. And there's no equality operator or anything defined, so the compiler has to just assume that one exists, and we'll need to somehow figure that out. I like using top-down operator precedence parsers, pret parsers for expressions. It's table-driven, so it's easy for code to add operators like XML and Haskell allows. Well, basically you could do the same with our parser if you think about it, because this whole this thing that I've shown you with the parse expression is basically a lookup table, just written out as a switch expression. If you factor this out into a table, it is basically table driven, and you can extend it with custom operators. My problem with that is that that leads to a whole lot of design debate and language design issues that we really didn't want to go into with Draco. So we didn't specify custom operators, at least not yet. It's probably not a direction that will take the language to. I wonder if we have a way to detect if something is an enum. So I'm just going to go into symbols and let's check if type symbol has something is enum. Nope. Does symbol have something like that? No. Okay. It should be relatively easy to add, I believe. So I believe that every enum is just inheriting from system.enum. So that's pretty convenient. We can check for that. So we can look into our well-known types and actually reference system.enum. This is why we made it. A source-generated thing, because we knew that this list would just grow the known things that our compiler would have to know. Are enums their own kind of symbol or just normal named types? Well, that's a tricky question. Currently, it's just something loaded from the BCL, so it gets manifested as its own symbol, if that's what you're asking. It gets manifested as a metadata module symbol, I believe, or even just a metadata class symbol, or metadata type symbol rather, and it would have members. And these members would be these public static literals. I believe this is why the metadata static field has a custom. Yeah, this is how we basically check if it's a literal constant that needs to be read out differently. And the only reference is in CodeGen. Yep. Oh no, we don't have difference between class symbol and the enum symbol. All metadata types are just metadata type symbol. We'll see if this is sufficient, or we'll need to split it up a little. For now, it's actually fine. So for type symbols, we have this pattern to query what kind of symbol something is. So we can define something like public virtual bool, not bool, but bool, is enum. And for the metadata classes, we can override this. Now, unfortunately, it's not flagged. I believe there's no type attributes for enums. It doesn't let me navigate into it. Wonderful. But just for safety, let me check. No. So what we're going to do is something closer to how we check for if it's a value type or not. Fortunately, we already have a pattern for this. Oops. So this is pretty easy. We can just check if it's an enum or not. Based on if the base type, any of the base types are system.enum itself. We might want to have a utility function called isDerivedType of something. But until I'm just copy pasting it in this class and it's just a couple of times, I don't mind it. So now we have a way to detect if something is an enum, but now we need to take care of the operators. And for that, we might want to hack it into the binder itself. So the binder is the thing that converts our syntax tree or the concrete syntax tree, the parse tree, into an abstract syntax tree. It looks up all the symbols and all the references. It does all the type checking, basically everything to be able to construct the AST for us, which is then a more convenient thing to desugar and generate code from. So we probably need to go into bind, I believe it's binary expression. And we have a bunch of special cases for and or and assignment, and this is the default lookup for them. Wouldn't it be better to have a type kind enum, since it's impossible for both? Example is delegate type and is enum type to be true. It's yeah, it would be. So on one end, you're totally right that for this case, that would be the better design. So people could do some switch cases and be sure that these things are mutually exclusive. But there's technically nothing stopping you from implementing system enum and some other nifty thing that we're probably going to check for later. Currently, these base types are fortunately mutually exclusive, so this one wouldn't be the case. But just in case, this might be a really, really bad case of Yagni that we're breaking here. That's the interesting thing, yeah. Enums are not value types. As in, the literal class itself is not a value type, it's just a sealed class. And you have these constant members here that get inlined during code generation. It gets completely erased even in MSIL already. The enum values are obviously value types, and if you ask the REPL thingy, it will probably say that it's a value type. Let's do string comparison. Oh, is that not a... That's an enum, right? Yes, it is. Are you a value type? It's also value type. That's interesting, because if you think about it, the type itself is not a value type. The thing that defines them. I suppose this is a special hack in their reflection system to report this as a value type. And this is a good point, because we're probably going to want to modify our isValue type to be isEnum or this. Do we compile directly to MSIL, or are we using some kind of IR? We actually have our own internal register-based bytecode, and this is because eventually we want to do some advanced stuff like vectorization, something that Roslyn and even Ryujit is currently missing. And we wanted basically an extensible platform to experiment with different kind of optimizations, so we designed our own bytecode. It's nothing out of this world. It's quite, it's your quite usual bytecode. And eventually we want to do vectorization, maybe with some link optimizations directly in there. We'll see how that goes. Also, just because I've been reading about this recently, do you use SSA for the IR at any point? I assume no, since it's register-based. That's not what SSA means, though. SSA means that your registers are assigned once. So there's only one point your VM registers have receive a value. Now, we do use SSA for that. What we don't do is use finodes, which reduces the number of mutation in your code in other places. We basically assume that you can allocate some memory on the stack, which is a local variable. And then you can sort of load from that memory, which is reading out of that variable, and store into that memory, which is writing some value into that variable thing. But the core representation itself and how we generate code is basically an SSA form. And this is how you would write some languages backend in LLVM as well. And it would, in the optimizer, it would start looking at your patterns and start turning your mutations behind mutable allocated memory into these compound finodes for you. We don't do that yet because we don't even have the concept of finodes yet. But if some optimizations rely on a lot of these mutations to be erased like this, we will eventually do that because it's quite possible LMVM does it, and it's not that complicated itself. So that was quite the tangent. And I completely lost track of what I wanted to do. We did is enum in metadata types, right? Yeah, we did. And oh yeah, we want to inject operators for certain things. And I believe the simplest way to do this would be to do it in build members. So when we're here, and if we are an enum, we're just going to inject the comparison operators. And how we're going to do that is that we're probably going to have some utilities in WellKnownTypes. Since WellKnownTypes is, well, it's not just WellKnownTypes, it's actually well-known operators and how you construct intrinsic operators. If you look at something like equals, comparison is basically building this thing, which in turn is get comparison operator name. Yep. So this is the thing that we'll probably need. And code gen equal is really easy. We just construct an equality instruction which maps one-to-one to a CEC instruction, which is, I believe, what we need. Yep. You load the two arguments and then you call CEC on it. These are private, which is not a problem. We're going to expose another way to do this because I want to cache. Well, we probably don't need to cache it since enum, all the types cache their members already. So once we constructed a comparison operator for them, we probably don't need to cache them. So let's do something like this. I don't know how I want to do this yet. I'm going to call these additives or mixins. Horrible name. But I don't have anything better in mind for this. And here we're going to have a bunch of methods, hopefully not for too many. but for the ones that we want to hack in these custom members. Let's do some basic checks just to make sure that we always call this API correctly. I suppose we can yield them. And then if we go back to type symbol, no, we actually need metadata type symbol. We can do result.addRange. How do we retrieve the compilation? It's metadata assembly, right? Ah, this is .assembly.compilation. Okay. Let's actually write some test code that can test this. We can delete this header, don't need it anymore, and let's import system itself. And we can do string comparison dot, let's do current culture. And yeah, current culture, ignore case. And then we are going to log if A equals B. Currently this is an overloading error because there's no operator. Let's see if adding this fixed it. Let's run it from the dev host. They're not equal. Okay, that's good. What if we change this to this? Then they should equal. All right, ship it. This was quite easy. So to have this reflected, let's rebuild the language server as well. And once it gets alive, it comes alive. Okay. Wonderful. Okay, I think this is a really good point to stop, because if you think about it, we achieved quite a lot with quite little. What we'll need to do next, which I'll do off camera, it's quite boring. We'll need to write some unit tests, and we'll need to investigate where the lookup went haywire with arrays, so it infers them to objects when we iterate over them. Now, before we end today's stream, are there any questions? Anything regarding the language, the compiler itself, or the session for today? I'll wait a few minutes and I'll get a glass of water. If you have any questions, drop it in the chat and I'll try to answer them. Okay, no questions. We had quite a few questions during the stream, which I was really happy about. People got interested in the thingies we were doing. So, thank you very much, everyone, for joining in. Soon I'll upload the VOD to YouTube as usual. And I'll see you at the next stream, hopefully, very soon. Bye, guys. Take care.